welcome to the first topic, number systems. So in this topic we look at some different ways of representing information, etc. So these things you're going to use all throughout, not only specialist maths but other maths as well. So you should have the number systems definition sheet, and that shows you the symbols and that's used, so you can work through that yourself and keep that as reference. A lot of those things you will have seen before, some you may not have. Okay, so basically we're looking at some sets here, and we are looking at sets of numbers basically. Let's have a look at an example of something we might look at. So this particular example, the universal set has the numbers 2, 4, 6, 8, 10 and 12 in it. We've got set C, which is the numbers 4, 8 and 12, and set D, which is the numbers 2, 6, 10 and 12. Okay, so that's our first lot of information that we need to work with. So with those sets of numbers, so a universal set is the top one there. That can be anything. It can be, all numbers, or it can be just a specific set of numbers. In this case, 2, 4, 6, 8, 10 and 12. So a few things we can do with that. First of all, we can illustrate on a Venn diagram. So on a Venn diagram, and hopefully, as you should know, a Venn diagram looks something like this. We have a box that represents the universal set, and we have a couple of circles in this case. One represents set C, one represents set D. Okay, so in the middle we put anything that is contained in sets C and D, and when you have a look at those two sets you should see that the number 12 occurs in both. Okay, then fill in the rest of the circles. So the other part of circle C is the things that are only in C but not in D. So things like 4, 8 and 12, not 12, let's get rid of 12. 4 and 8, I should say, are in there. And in set D we've got 2, 6 and 10. Now outside those circles in the rectangle there, we put any other numbers that there may be that are not contained in either of those sets. And in this particular case, that doesn't happen. There are no numbers that are not in either of those two sets. So this is where we come and we look at our get rid of that, and we can write down then sets of the following. Okay, so we need to find, first of all, we're going to find C dash. So C dash, or C complement, means everything other than the stuff in C, things in C. So everything other than in C is, in this case, the ones in D only, which is 2, 6 and 10, and anything else that may be outside all those circles. Now in this case there is none of those. So it's simply 2, 6 and 10. B, C union D. U, union, means it can be so things in both of those. Put both of those together, sets together, and everything that's in that. So those numbers are 2, 4, 6, 8, 10 and 12. Now the number 12, we only write it once, we don't write it twice. We don't count it twice, we only count it once. Yes, it is in C and it is in D, but we only count it at once. So getting onto that intersection, so that's that upside down U, C intersection D, that's the ones that are in both, and this is the number 12 that is in both. Let's look at another one. D, let's look at something like this, C union D, complement. So we're going to have a look at that. C union D was up in example B. So it's everything that's not in that. And in this particular case, there is nothing. So that's the null set. So you can write that two different ways. We could write it like that, or we can write it like that to represent the null set. Okay, and so there's a whole bunch of other different things we could do if we wanted to. That's just a few examples. Alright, so I guess the nomenclature, as it's called, notation, the way we symbols and that. So you need to know those and their meanings. Okay, so sets of numbers. We have a few different sets of numbers, and again you've got the definitions in front of you. So real numbers, integers, rational numbers, irrational numbers, natural numbers, and complex numbers. Okay, so if you look in your textbook on page 5, in the middle of the page there's a nice diagram, and it shows you how it all fits together. So you'll notice that. So we've got our real numbers there. Then inside that we have our rational numbers, and then completely contained inside that we have our integers, and then completely contained inside that is our natural numbers or our counting numbers. And then there's another circle out there which is irrational numbers. So Q, rational numbers, they're things that can be written as a fraction or ratio. So real numbers are all the numbers that you currently know about. Although there are complex numbers, imaginary numbers, and we will get to those. At the moment, the real numbers are all the numbers that we know about. So that's in our universal set. Rational numbers are anything that can be written as a ratio or a fraction. Z, our integers, that's like all our whole numbers. And then inside that we've got our natural numbers. Now natural numbers are our counting numbers. So that's the ancients, they didn't have 2.5 people or anything like that. You either had 2 people or 3 people, so they are natural counting numbers. And of course over here is our irrational numbers. They're the ones that can't be expressed in a fraction form. So things like pi, square root of 2, those sorts of things. Okay. So getting back to our irrational numbers, integers, natural numbers, that's where our subsets come in. Our natural numbers are a subset of integers, and our integers are a subset of irrational numbers. Okay. Alright, so you just need to be able to identify numbers and those irrational numbers, irrational numbers, etc. Let me have a look before we get started on that. And that's about it, really. Let's have a look at the example about something to do with rational numbers. Okay, So, for example, let's have a look at these numbers here. Okay, so state all the sets. The following. Numbers belong to. There we go. So let's say, for example, the number -5. Okay, so what can we say about the number -5? Well, the number -5, of course, is a real number. Okay. Secondly, can we express it as a ratio or a fraction? Yes, we can. There's a whole host of different ways we could do that. So it's also a rational number. Are there any other? Is it a natural number? Well, no, it's not one of the natural counting numbers that the ancients would have had. And is it an integer? Well, is it a whole number? Yes, it's a whole number. It's a negative whole number. So we could say it's an integer, yeah, but we could also z minus, so it's one of the negative numbers. So it's a negative integer. Alright, here's one B, for example. Okay, so let's have a look at this one, -16 on 3. Let's have a look at that. Now, is it a real number? Yes, it is. Is it a rational number? Can you write it as a ratio? Well, it already is written as a ratio. 17/3, a fraction, is a ratio, so it's cubed. That's it. It's not a natural number, not a normal counting number. It's not a whole number. So they're the only two that it belongs to. A few more. So the next one, 3√2, for example. What sort of number is it? Well, as I said, the square root of 2. I mentioned already before, is one of those examples of irrational numbers, and of course, yes, it is a real number. Okay, so let's have a look at another couple of examples using those same things. So the number 27.179, and we'll have some recurring here. Okay, so the question is it a real number? Yep, okay, it's a real number. Is it a rational number? Well, when you have a look at this, it's got some recurring, but you notice that 179 has the dots above it, so it goes 179, 179, 179 continuing. And whenever you have a pattern like that, it turns out that yes, it would be a rational number. You would be able to express that 179 recurring as a fraction if you wished. And that's it. It's not a whole number, it's not a counting number. What about something like this, 4.153? That's it, it finishes there. Again, it's a real number. Is it a rational number? Yes. Well, that 153 can be expressed in a ratio or a fraction, and it will be 153/1000, so it's part of Q also. Alright, so that is it as far as what we're doing for the rest of this exercise. There's a couple other things that we're not looking at in there, so we won't worry too much, we won't worry at all about those. So first set of questions. Question set number 1, you've got the handout which tells you what all the questions for that are, so you can make a start.